right, so our first presenter is going to be Samin Ashjaei, Communication Science.
All right, I have a question for you. Have you ever thought that when you are exploring the relationship between variable A and B in your research, there might be actually a variable C that is explaining the whole relationship? That's always a possibility when we don't have enough control over our variables. Now imagine aging as your variable. Aging is not a variable that you can randomly assign people to. You cannot say that, okay, you age, you don't age, and then in the long term I will compare your outcome. And so basically there is no perfect way to attribute the consequences of aging to one or two single variables. I studied the effects of aging on speech in noise recognition. You have seen older adults in restaurants that they cannot keep up with the conversation simply because there is noise in the background. Most of the literature believe that that's probably and most probably related to having some sort of age-related hearing loss. Basically, they believe that older individuals have probably some level of hearing loss that is causing the decline in their speech input perception. But we tested that. We tested individuals only with typical hearing, with normal hearing, and we were more interested to see if there is something going on in their brain, specifically changes in their brain volume that is driving the whole impact. To test that, we developed a statistical toolbox called GMAT that allows us to test all of these passes. This is called mediation analysis. Mediation analysis basically helps us to get closer to that third variable behind the scene. In our case, the third variable was changes in brain volume. We tested all of these passes and we found out that regions responsible for sustained attention, regions responsible for selective attention, our ability to transfer basically switch our attention from the background noise to the targeted speech that's necessary for understanding the speech in the background noise, as well as regions responsible for motor control, precision of our motor control, when we hear integrate in our brain and we want to produce accurate speech. And eventually the regions that are responsible for transferring information between subcortical regions to higher order cortical processing are driving this impact, this relationship. And we believe that our findings have the capacity to inform clinical cognitive interventions that eventually can help older adults have better speech input perception. Stay tuned. Thank you so much.